welcome to the channel of Ecoholics. So in this video, I will be discussing the injective functions. Functions are very simple and they are the first topic from which mathematical economics also start. So when it comes to functions, the different type of functions makes the top priority in the questions which you can expect in your entrance examinations. So let's just understand the first and the most important type of functions, which is known as injective functions. So we also call our injective functions as one-to-one functions. So why one-to-one? Because of their special characteristic. So the injective functions are those functions where we map distinct elements to distinct elements. So a function takes value from domain to codomain or to range over here. So if one element goes to one element only, that is your injective function. Because if two elements from your domain are going to just one single element in your range, that is not your one-to-one. That thing you don't want in your function. So I do not want this case where two functions are going to just a single element in the range. I want one individual element to go to an individual element in the codomain. And same for everyone over here. Although I can have free elements here. I can have free elements here. There are no restrictions on that. But no single element in the range should be taken up by two elements in the domain over here. So if f is a function where a is domain and b is range, it's an injection if it's a one-to-one function. And how can we prove it? Proving or checking one-to-one function is really easy. So what I'm saying is I need every element of domain to go to every distinct element in my range. So to prove whether a function is injection or not, I can start with contradiction. I will say, okay, x is an element which is going to same number and y is an element which is also going to same number. So the value the x is taking and the value which y is taking are exactly same. It means they are going to same element. So if it is the case, the function should not be injective. But by starting working with this, if towards the end I can prove that no, x is equal to y only, I can show that my function is injective. So I started with contradiction that the value x and y are taking is exactly same. But towards the end I showed that x and y are not different. They are exactly the same element. So if they are same element, their values has to be same. It means no two elements which are different, but they have the same value in the range. That is how I show it. So this is an example over here of one-to-one function. You can see 1 is going to 1, 2 is going to 4, 3 is going to 9 and 4 is going to 16 over here. So let's understand with the help of one example to check whether we have an injective function or not. So we have given a function r to r, fx equals to 2x plus 1. We have to tell whether this function is injective or not. So let's start with fx equals to fy. So in place of x, if I put x, I'm going to get 2x plus 1. In place of x, let me put y, so I get 2y plus 1. So 1 and 1 cancel out each other and I'm left with 2x equals to 2y. 2 and 2 also cancel out each other and x is equal to y is proved. So I have proved that only if x will be equal to y, their value can be same. So it means the given function is injective. So with this very easy technique, you can prove that a function is injective or not. Please like this video. If you find this video useful, share it with your friends as well. Subscribe to the channel. Thank you everyone for watching.